So next we will discuss about the types of the steam. So basically the steam are classified into three types, that is wet steam, dry saturated steam and then the superheated steam. So what is mean by the wet steam? Wet steam is defined as it is a two-phase mixture of the water molecules entrained in the steam. Okay, it is a two-phase mixture. Which are the two phases are? Like one is the water molecules which basically entrained in the steam. Okay, so that is what we call it as a wet steam at a given like a saturation temperature and also corresponding to the pressure. And then similarly, what is mean by the dry saturated steam? So when we keep on heating this wet steam, okay, so whatever the water molecules are there in the wet steam, they also starts to evaporate and convert it into the like a steam. So in the dry steam, it is defined as the steam in which, okay, there are no water molecules in it at a corresponding temperature and at a corresponding pressure. So that is called as a dry saturated steam. And then what is mean by the superheated steam? So if we keep on adding the heat, okay, beyond the saturation temperature, the temperature of the steam like increases. So the dry steam will be converted into the like a superheated steam. So the superheated steam can be defined as it is the steam, okay, so which is heated behind the like a saturation temperature, it is called as a superheated steam. Likewise, we can classify the types of steam into the three types, that is wet steam, dry saturated steam and then the superheated steam. In the wet steam, it contains a two-phase mixture, that is it contains water molecules, certain amount of water molecules, as well as the steam, like they are in thermal equilibrium, so at a given pressure and then the like a saturation temperature. In the case of a dry steam, we don't have any water molecules, so all the water molecules will be like converted into the steam. Whereas in the case of a superheated steam, we are going to heat that temperature like the dry steam, okay, so if you continue heating that, it will be converted into the superheated the steam. So likewise, you can classify types of steam as wet steam, dry saturated steam and then the superheated steam. Next we will go to the topic which is called as like a steam properties. So what are all the steam properties that we are going to discuss are, the first one is the dryness fraction, enthalpy of a steam, and then the third one is the specific volume, and then the fourth one is the internal energy. So for all the three types of the steam, we are going to discuss about all these properties. Like first we will take the dryness fraction. So dryness fraction, it is given by the symbol x, okay, the small letter x. So it is basically the ratio. In the numerator we have mass of the steam in the like in the wet steam, like a mass of the dry steam in the wet steam, that is in the numerator, and then the total mass of the wet steam. So that is x is equal to mg by mf plus mg. What is mg? It is m represents the mass, okay, g represents the dry steam. So mg is the mass of the dry steam present in the wet steam. So divided by mf, m represents the mass again, f is the like mf plus mg is the total mass of that wet steam. Okay, it is basically the ratio of the masses. It doesn't have the units because numerator also you have the mass and denominator also you have the mass. It doesn't have any units. It is the mass, it is a ratio of dryness fraction can be defined as a ratio of mass of the dry steam present in the wet steam divided by total mass of the wet steam. Okay, so in the form of the equation we can write x is equal to mg divided by mg plus mf. Okay, so this is the equation which we use for the like calculating the dryness fraction of the wet steam. So later we will go to the next property, that is called as the enthalpy of the steam. What is mean by the enthalpy? First we have to understand before going to the enthalpy of the different types of the steam. The enthalpy of the steam is defined as it is a summation of the internal energy like a plus the pressure multiplied by the volume. Okay, so in the form of equation we can write it as H is equal to U plus PV, where U represents the internal energy and then P represents the pressure and V represents the volume. So enthalpy is the summation of internal energy plus the pressure times the volume, it is called as a enthalpy. So let us discuss the enthalpies for the different types of the steam. The first one is the enthalpy of the wet steam. Okay, so what is mean by the enthalpy of the wet steam? So it is the enthalpy of the wet steam can be defined as the amount of heat supplied in order to convert 1 kg of the water which is at 0 degree centigrade, so into the like a 1 kg of the wet steam, okay, at its saturation temperature and the corresponding pressure. So how much heat you are going to supply to convert, we take the water at 0 degree centigrade, so which is 1 kg. So in order to convert that into the like a wet steam which is also the same mass of 1 kg at a saturation temperature and corresponding pressure, it is called as a like a enthalpy of the wet steam. There is an equation for the enthalpy of the wet steam that is given by HW is equal to HF plus X into HFG. While discussing about the like a temperature enthalpy curve in the previous section, that is a steam formation, we know that HF is the enthalpy or the sensible heat, we call it as, that is amount of heat required to rise the temperature of the water from 0 degree to the saturation temperature, plus X is the dryness fraction. We have discussed what is mean by the dryness fraction. It is the mass of the dry steam to the mass of the total mass of the wet steam, like a, which is multiplied by HFG. HFG is the like a latent heat or the latent heat of evaporation. So the enthalpy of the wet steam is given by summation of the sensible heat, that is HF, and then the dryness fraction times the latent heat of evaporation, that is given by HFC. Normally the enthalpy has the units of kilojoules per, okay, so it has a units of kilojoules per kg. Okay, so next is enthalpy of the dry saturated steam. So what is mean by the enthalpy of the dry saturated steam is, so it is defined as the amount of heat supplied in order to convert the water which is at 0 degree centigrade, 1 kg we will take the mass of the water at 0 degree centigrade into the 1 kg of the dry steam, okay, at the corresponding pressure and temperature. So it is called as the enthalpy of the dry steam. So like we take the 1 kg of the water, the temperature of water is initially at 0 degree centigrade, we keep on adding the heat. So the saturation temperature is reached, and then after the saturation temperature it absorbs the like a sensible latent heat of evaporation, and it is converted into the dry steam. Okay, until that point from 0 degree centigrade of the water, 1 kg of the water, it is converted totally into the dry saturated steam. That is means there is no water particles in it. Okay, until that time how much heat you will add it to the water, that is called as the enthalpy of the dry saturated steam. So also we have this equation in order to calculate the enthalpy of the dry saturated steam, which is given by Hg is equal to Hf plus Hfg. Okay, so Hg is what? Enthalpy of the dry saturated steam, which is equal to summation of the Hf, that is the sensible heat, plus Hfg, which is the like a latent heat of evaporation. Okay, if you add the sensible heat and latent heat of evaporation, you will get the enthalpy of the dry saturated steam. As I told before, so as I discussed before, Hf is sensible heat, that is the amount of heat required to rise the temperature of the water from 0 degree centigrade to the saturation temperature, and behind that if you keep on adding the heat, that is called as a latent heat of evaporation, that is Hfg. Okay, it is at a constant like a saturation temperature, that is what we are going to supply the heat. Okay, so it is Hg is equal to Hf plus Hfg, or the enthalpy of the dry saturated steam is equal to the enthalpy of the sensible heat plus the latent heat of evaporation, which is also has the units of kilojoules per kg. So similarly we have the enthalpy of the superheated steam. Okay, so we are going to, if you keep on supplying the heat to the dry saturated steam, it will enter into the like a superheated state. Okay, so what is mean by the superheated steam is nothing, enthalpy of the superheated steam is, it is the amount of heat supplied, how much heat you are going to supply to the 1 kg of water at 0 degree centigrade, that is the initial temperature of the water, until, okay, so in order to convert that into 1 kg of the superheated steam, okay, at a given superheated temperature and at a corresponding pressure. So that is nothing but the like a enthalpy of the superheated steam. Okay, I am going to repeat that definition of what is meant by the enthalpy of the superheated steam. You take the 1 kg of the water, which is the initial temperature is 0 degree centigrade, and at a given pressure P, and then if you keep on adding the heat, so how much heat will be going to supplied in order to convert that 1 kg of the water into 1 kg of like a superheated steam at a given superheated temperature, and then the corresponding pressure, it is called as the enthalpy of a superheated steam. So we also have an equation for the superheated steam in order to calculate enthalpy. H sup, okay, SUP represents the superheated, H represents the enthalpy, Hg plus Cps into T SUP minus of Ts. So let us try to understand different notations what we have here. H SUP is the superheated enthalpy of a superheated steam. Hg, it is nothing but the enthalpy of a dry saturated steam. Cps is a specific heat of a steam, and then TSUP is a superheated temperature, and TS is the saturation temperature. So we can say that the enthalpy of a superheated steam is equal to summation of the enthalpy of the dry saturated steam, that is the Hg, plus amount of superheat we call. Okay, so this whole like a thing, okay, this is called as the amount of superheat, which is given by Cps, that is a specific heat of the steam, multiplied by superheated temperature minus of saturation temperature will give the amount of superheat. So if we add the sensible heat and then the like amount of superheat, you will get the enthalpy of the like a superheated steam. Okay, so how much heat you are going to supply in order to convert 0 degree 1 kg of water into the 1 kg of superheated the steam. So if you replace this Hg by Hf plus Hfg, okay, we know that the enthalpy of a dry saturated steam is summation of the sensible heat plus the latent heat of evaporation, and then this term is replaced by these two terms. So this we will retain as it is. So we can write it in other form as the enthalpy of a superheated steam is equal to the sensible heat plus latent heat of evaporation plus amount of superheat. Okay. Likewise, we have discussed about the enthalpy of the steam, in that enthalpy of the wet steam, and then equation, and enthalpy of the dry saturated steam and enthalpy of the superheated steam, and then what are the formulas we need to remember like for calculating all those enthalpies of a different types of the steam. So next we will go to the next property of the steam, that is a specific volume. What do you mean by the specific volume? It is again the ratio, okay, it is a ratio of volume per unit mass of its substance. Okay, in the numerator you have the volume, and in the denominator you have a like a mass. The unit for the volume is meter cube, we all know that, and then unit for the like a mass is kg. Since that volume is in the numerator, meter cube in the numerator, and then the mass in the denominator, kg will be in the denominator. So if you write the like a unit for the specific volume, it is meter cube per kg. That is a volume per unit mass of a substance, it is called as a like a specific volume. So we will try to understand what is the specific volume of saturated water. So it is nothing but volume occupied, okay, by the unit mass of or 1 kg of, okay, saturate like a 1 kg of water, okay, or the saturated water at its saturation temperature. Okay, when you heat this water which is at 0 degree centigrade, and then the temperature of that water increases until it reaches the saturation temperature, and then if you take that volume at the saturation temperature, so what is that volume of 1 kg of saturated water at the saturation temperature? It is called as the volume, specific volume of a saturated water. It is denoted by like a symbol Vf. And then specific volume of a dry saturated steam. So again it is the volume occupied by the 1 kg of a dry saturated steam. It is called as a like a specific volume of a dry saturated steam. It is denoted by the symbol Vg. And then we have something called as specific volume of the wet steam. Like a wet steam, it is a mixture of the steam and then the water molecules we have. So if you take the wet steam volume, you have to add the dry steam, and then you have like a volume of the dry steam plus the volume of the water molecules. Okay, so there are two parts in this one. So if you take this formula, look at this formula, Vw is equal to x into Vg, that is dryness fraction times the volume of the dry saturated steam, and then plus 1 minus of x, that gives the amount of water molecules in that particular wet steam multiplied by the Vf, that is the like a volume of the like a saturated water or the water molecules. Okay, this is a formula. Vw, that is the volume of wet steam, is equal to dryness fraction, that is x times the Vg, that is the volume of the dry saturated side, plus 1 minus x into the Vf, that is the volume of the dry saturated water. And similarly we have the specific volume of the superheated steam. So what is it is also a the volume occupied by the 1 kg of the superheated steam, it is called as like a specific volume of superheated steam. So we, according to the Charles law, we have the volume occupied by the dry steam to the saturation temperature, which is equal to volume occupied by the superheated steam to the superheated temperature. So we are interested in volume of the superheated temperature. We will keep this like a volume of superheated temperature on the left hand side of the equation. If we send this to the other side, so this becomes Vg divided by Ts. Vg is volume of the dry steam, okay, Ts is saturation temperature, which is multiplied by the like a superheated temperature, okay, then which is again given in the units of meter cube per kg. Okay, this is about the specific volume of the steam, which is also one of the important property. And then how do you represent, okay, what is the definition of the specific volume of different types of the steams we have discussed until now. Next, the last property that we are going to discuss about the steam is, it is the internal energy. So internal energy is nothing but it is the difference of the enthalpy and product of like a pressure into the volume. I am going to repeat this. So like a internal energy is given as, it is the difference of enthalpy minus of like a pressure times the volume. So you can write it in the form of equation, U is equal to H minus of PV. So here U is the internal energy, that is a symbol we are going to use for the internal energy, and then H is the enthalpy, minus of P is the pressure, and then V is the volume. Okay, so if you multiply pressure and volume and then take the difference, okay, from the H, you will get the internal energy. And then internal energy of the dry steam is given by Vg is equal to Hg minus of P into Vg, where Ug is the like internal energy of the dry steam, Hg is the enthalpy of the dry steam minus of pressure, corresponding pressure, times the Vg is the like a volume of the dry steam. G always represents for the steam. Okay, so and then internal energy of the wet steam is given by, so UW is equal to, okay, HF, that is the like a sensible heat, plus X into HFG. X is the dryness fraction times the HFG is the like latent heat of evaporation, minus of P. P is the pressure, corresponding pressure. X is again the dryness fraction, Vg is the volume of a dry saturated steam. Okay, so if you want internal energy of the wet steam, you have to use this formula. UW is equal to HF plus HFG, X into HFG minus of P into X into Vg, sorry, kg per kilojoules per kg. Okay, that is the formula. And then the last one is internal energy of the superheated steam, which is given by U SUP, that is the internal energy of the superheated steam, is equal to H SUP, that means enthalpy of the superheated steam minus of pressure times the volume of the superheated steam. It is also given by kilojoules per kg. Okay, like this we can write the internal energy for all the three different types of the the steams here. Okay, different types of the steam. So that is what the properties, important properties of the steam. So in order to summarize this, okay, what are the different properties are? We have the steam properties are dryness fraction. It is a mass of the dry steam to the total mass of the wet steam. Enthalpy, which is nothing but the summation of internal energy plus pressure into the volume. And then enthalpy of the wet steam is given by like a sensible heat, HF, plus dryness fraction times the HFG, that is the latent heat of evaporation. And enthalpy of the dry saturated steam is given by Hg is equal to Hf plus Hfg, that is sensible heat plus latent heat of evaporation. And superheated steam, we have the enthalpy is given by Hg plus Cps into T SUP minus of Ts. Here this is the enthalpy of a dry steam plus amount of superheat. If you add them, you will get the enthalpy of a superheated steam. Specific volume for the different types of the steam, we have written it here. That is for the saturated water, that is a 1 kg of like a saturated water occupied at the saturation temperature, it is represented by Vs, and 1 kg of like a saturated steam, dry saturated steam occupied volume, okay, so it is called as a specific volume of a dry saturated steam like a Vg, and specific volume of the wet steam is given by this equation, okay. Likewise, we have also written it for the specific volume of a like a superheated steam, and then internal energy for the different types of the steam, okay. So this is about the different properties of the steam. So next is like a applications of the steams, okay. Applications of the steams, if you talk about, okay, steam as a many applications, okay, it can be used like in the steam turbines, for example, and then the thermal power plants, like where boilers are used in order to generate the steam, and then that steam can be passed over the turbine. So there the energy which is stored in the steam can be converted into the mechanical energy in the turbine, and then from the mechanical energy we can produce the electricity. Likewise, so steam has like many applications. So thank you.